Welcome to Unlock Layouts. In this video, we are going to discuss the topic of deep Nwell. Let's start the video. So here we have a deep Nwell concepts and deep Nwell discussion today. So generally, if you refer any kind of books or if any kind of materials, so generally you will get the answer. Deep Nwell is a layer which will give the isolation between the local substrate and the global substrate. Only based on the single line of the definition about the deep Nwell, so we cannot able to understand what is deep Nwell and where it is exactly used and how the deep Nwell is useful in the different situations. So or else some particular situation deep Nwell is very useful. See, generally this is the deep Nwell structure diagram, which is a cross-sectional diagram of deep Nwell. Deep Nwell layer is also similarly like a Nwell layer. So there is no difference between Nwell and deep Nwell, but deep Nwell layer will be trenched deeper than the Nwell. So for example, in this figure 1 you can able to understand. So in our P channel MOSFET, underneath of the P channel MOSFET, so we have a Nwell layer. Okay, this is trenched. Okay, so the Nwell layer is having some trench, which means some deeper of the area. So underneath of the Nwell, so we will get the deep Nwell layer junction. Deep Nwell will be used in the particular situation. So we'll discuss right now. See, only based on this, only based on the cross-sectional diagram also. So you are not able to understand, or you cannot able to understand what is deep Nwell. We'll take a real-time example of deep Nwell. So this is figure 2 is our normal CMOS cross-sectional view, and this is the normal deep Nwell cross-sectional view. Okay, so we'll discuss all those details and all we'll discuss later. So before discussing all those things about deep Nwell, we'll take a look of on schematic. So in that schematic you will easily understand what is deep Nwell. See, now we have two devices. The device name, one is called M0 and the one more device, the name called M1. M0, M1 is the two devices which is N-channel MOSFETs. So these are all the N-channel MOSFETs, and the both N-channel MOSFETs having 4 terminals. See, the first M-channel MOSFET M0, I have assigned the drain terminal is called VDD, and the source terminal is assigned for ground, and the gate signal I have assigned for A. And then here the body and the source both are connected together. So generally N-channel MOSFET body will be connected to the source signal. So that is the general connection. Most of the time the substrate of the NMOS will be by default will be connected to the source terminal of the NMOS. So this is the general connection. So for this situation we don't want deep Nwell. So the normal NMOS, the normal NMOS ring, it is sufficient to complete the normal process. But we have a second situation here. See, we have two different devices in the same schematic. One is M0. M0 body is connected to the substrate connection, that is by default connected to the ground connection. We have a M1 devices. M1 devices also having the 4 terminal, gate, source and as well as drain. See, gate I have assigned for net name B, and then drain I have assigned the net name for VDD1, and then the source connection I have assigned the net name for ground. But the M1 device body, this is not connecting to the source of the MOSFET. This is getting the different signal, which means this is not a ground and this is not a power. So every time most of the circuits N-channel MOSFET body by default will connect to ground signal. See, most of the time, so we have a cross-sectional view as NMOS. See, most of the time the NMOS source connection and as well as body connection, these both has to connect to ground signal. Okay, so this both always which will be connected to the ground signal. So that is what we are doing in our layout session. So the same connection. Okay, so particularly for NMOS, not for PMOS, because PMOS having the local substrate of Nwell. So this is completely isolated in the sense this is not a global substrate, this is the local substrate. See, this Nwell substrate only used for the particular PMOS. So we are not going to share any Nwell here. A single PMOS having the single Nwell. So the P substrate is the global substrate. Okay, so which is the global substrate means, so it is also for N mass and it is also for P mass. See, underneath of the P mass also some P substrates are there. Underneath of the N mass is also the same P substrate is there. Then we'll go to our schematic. See, this is our schematic. See, our situation is totally different here. Suppose if the both P masses, if the both N masses, for example M0 and M1, if the both body is connected to the ground signal, then we don't have any problem. A single substrate connection is sufficient to clear the LVS. But now in our situation, body of the M1 which is connected to ground and source and body is connected together, and by default N channel MOSFET body will be connected to ground. So this is our typical case, and we have one more special case. So in my special case, my M1 device source is getting different signal, drain is getting different signal, and as well as gate is getting different signal, and also body is also getting the different signal. So all the four terminals are getting different signal. See, source, drain, gate. So these are all the source and gate or drain, these are all the negligible cases. So whatever the signals are getting source and gate and as well as drain, so we'll completely avoid. The particular thing is here is the body connection. So very particularly body connection. See, when the both N channel MOSFETs are in the same circuit, in the same die, in the same wafer, but one MOSFET is connecting to the ground signal and one MOSFET is getting the signal of body, right? So body in the sense, this is not a ground, this is not a power. So body is the totally different signal. Okay, this is not a ground signal. And then now I have a equivalent layout here. See, for example, before checking everything, right, once I'll show how the circuit diagram and how the connections are given here. See, this is our M1 device. M1 device, see the drain of the M1 device, I have assigned the pin name called VDD. So this is the drain. And then we have a gate. So gate, see here I have assigned on via and I have assigned the name called A. So this is A. So here this is our source terminal and this is our guard ring. So guard ring in the sense that is our substrate connection, body connection. So both I have connected through M1 and I have assigned the name called ground. So here I have assigned the pin name. The pin name is called ground. The first M1 circuit which is very much equivalent in layout, so there is no errors at all, everything completely alright. And then second we'll come to the M2 device. So right side we have a M2 device. So we will check the M2 device connections also. See, now we have a drain connection. So drain I have connected and I have assigned a name for VDD1. Then we'll go for the gate connection. So this is our gate connection. See, gate connection I have assigned the pin name called B, and as well as source connection. Source which is not connected to the body, still it is floating and still it is getting the signal name called GND1, which is ground 1. So this is our ground 1 that is connected to source of the M1 MOSFET and body. So body is not shared to any net, it is still floating from the minimum DRC distance, and see, I have assigned the pin name called body. So whatever the signals and whatever the net names I have assigned in the schematic, the same net name and the same name I have instance I have connected, I have given the connections through the layout. Once we run the LVS, we will come to know what kind of error we are getting from these kind of circuits. See, now our LVS is run successfully, but in our LVS, even though our schematics and layouts are same, but we are getting a error. What? The LVS is not clear. Still the LVS is not clear. See, you can able to see this X mark. LVS is still, it is showing the incorrect net. But if you see the details of the devices and connection, see, we have a port, 7 port. In source also 7 ports are there. In layout also 7 ports are there. So it is equal. Net, we have a 7 connections and source 7 connections. So both is equal. Instance, we have 2 devices, M0 and M1, that is in layout also 2, schematics also 2, and we have 4 pins, M and pin. So all the 2 devices are having 4 pin devices. Everything is equal. Okay, so there is no device parameter wise error, connection wise error, nothing is there. See, even if you can able to see here top of this, see, we have a count 2. Okay, this will check it, what is the count 2. Net is equal. instance is equal, port is equal, everything is equal, which means connection wise everything is correct, but still the tool is showing some error. So what kind of error? See, the post through error is the, see the third part, which is the, see it is showing pass through the layout net names are some error which is called body. So here it is very clearly telling there is a some different signal or different net which is called body, which is creating the problem here. Then we will see what kind of error the net is showing. First we will check the dispensary one. See, in this dispensary one it is showing in source body is there, in layout net name body is there, but in M1, okay, so here it is showing, see in M1 source it is body, but layout it is showing missing connection. What it is showing exactly? M1, so this is, that is called our M1. So this is our M1. In our M1 body terminal is there, which is assigned the name of body, but when we are coming to the layout session it is showing it is not connected. But when you take a look of the layout, right, see this is our layout, I have clearly mentioned that this is our substrate connection, so this is our body. See, I have assigned the net name, so this is our net name. Just I will queue it and see the property of the device. So this is our net name M1 pin, I have assigned this is body. Even though the port name and pin names are there in the guard ring, but still our tool is showing it is not present. And second thing, one more second dispensary, it is showing like, see in layout ground is there, okay, so in source it is ground, but here the different name is assigned in layout which is called B. So the tool itself, it is not able to identify what kind of error it is. See, this is our detailed info. So in our detailed info, see what error it is showing. Detailed info in the sense M0 device, M1 device. So both the device, body, source, drain, everything is equal, but gate, source, drain, everything is equal, but body connection here it is assigned as a ground, where in M0, but see M0 it is assigned as a ground, G and D signal I have assigned as a G and D, but in source it is assigned as a body. See, there are totally the tool itself getting confused, but everything is equal here, but still the caliber it is showing we are getting some error, and we will go to the soft check database. So in the soft check database, so here we have an option called the soft check database. In the soft check database it is showing exactly, this is showing what kind of error. See, P substrate is the problem. Second thing, P substrate contact is the problem. So everything is correct, right? So most of the things are correct here, all the things are, everything is correct. So connection wise also, pin name wise, everything is correct. Even the caliber RV is showing, so we have a problem with P substrate, we have a problem with P substrate. See, this problem only happened with the N channel MOSFET, not with the P channel MOSFET, because P channel MOSFET is having the separate substrate, okay? N channel MOSFET is having the global substrate which is called P substrate. So here the soft check error is clearly telling that there is a problem with P substrate, but everything is proper here, okay? So everything is proper here, connection wise everything is proper here. See, now the peoples who are all watching this video, so did you got any idea why the tool is showing the conflict error? So there is a conflict between the body. Why there is a conflict between the body? Okay, so here we are not able to understand why it is showing the conflict. Just I will show you the one more slide. So in that slide you will understand very easily. See, this is what the connection we have in our layout. So we have a two NMOSs. So this is NMOS 1 which is M0, this is NMOS 2 which is M1. See, gate signal is assigned as a, okay, and one more, drain signal is assigned as VDD, and source signal in M0 device, source and body. So this is our source terminal and this is our substrate terminal which is body terminal which is guard ring. So both nets are connected to ground, and then we have a NMOS, one more NMOS which is called our M1. So in our M1, see, gate is assigned as a B and source is assigned as a ground 1 and drain is assigned as a VDD 1, and substrate connection which is our body connection which is assigned as a body. So this is our circuit here. See, in right side we have the device, right? So this is our M0, this is our M1. Both the signals are equal signals. See, now this is what our cross-sectional diagram. So this is, I told you, right? So we have to refer 3-4 diagrams to understand where exactly the errors are getting pop-up. See, now we have a n mass which is M0 and M1. The problem which is very clearly telling it's because of the body. Since, right, so you can see the problem here, why it is popping up. See, the n mass device having the global substrate which is called P substrate. So whatever the yellow color highlight here, this is our P substrate. The first M0 n mass is also having the same P substrate, and M2 and M1 n mass is also having the same P substrate. See, either this should connect to ground or either it should connect to body, which means the substrate is the one, it should get only the ground signal or else it should get only the body signal. But in our schematic, even we have a same substrate, okay, the both n mass is having the same global substrate, but the first n mass which is called M0 n mass, which is getting the substrate connection of ground. Okay, see, now in our n mass, right, so this is where our first M0 body connection and ground connection and as well as the substrate connection is there. See, since the M0 n mass which is connected to the ground, so it is injecting here and this is injecting here. So once it is injecting the ground signal here, the entire P substrate is having the ground signal. But one more n mass we have, so which is called the M1. So these n mass potential of the body, this is P substrate, the body of these n mass, so the body of these n mass is connected to the different signal. So this body of n mass, right, this is different signal which is getting. So this is not a ground, it may be a positive signal, it may be a negative signal, it may be any signal, but this is also injecting the same signal which is different signal, also injecting to the same substrate here. So this is a kind of problem what we are getting with this kind of structure. Either the entire substrate should be connected to the ground or either the entire substrate should be connected to the body or any different signal or the both, it's a common signal. But in our schematic, right, the first n mass which is getting ground, okay, this is purely connected to the ground, but the second n mass which is directly connected to the body. So that is why the tool is showing there is a problem between the body, that is called the substrate. So for the M1 device it is showing it is connected to ground, for M0 device it is showing it is connected to body, right? But why the tool is showing this kind of error? Because this, so it's a Nwell process. I am talking about the manufacturing process of the CMOS. It is purely based on Nwell CMOS fabrication process, which means the P substrate is the global substrate. Either this global substrate should connect, always this global substrate should connect to ground signal, but in our circuit there is some special device. So in that special device, one separate MOSFET which is not connected to the, which means the substrate is not connected to the body. So this is getting totally different signal. So in this case, what to do? So that is our question. See, now we will understand why the tool is showing the soft check error or the conflict error based on the body connection. So this is why the tool is showing the body connection is wrong, because both n mass is having the same global substrate, but one n mass is getting ground signal and one n mass is getting the body signal. So body in the sense this is different signal. So we can assign the name for any kind of signal, but generally I assigned it's a body. So one is getting ground signal and one is getting body signal. Both the nets or both the signals are different signal, but both the different signals are injecting to the same substrate. So that is why the tool is showing we have a problem with the body connection. So this is why the tool is showing this kind of error. See, we have elaborated completely why the tool is showing this error, because since based on this schematic diagram, some people they cannot able to understand why it is showing. Okay, so that is why I have given 3 different classification. One is like based on the schematic view, and one is like based on the layout view, and one is like based on the cross-sectional view. So we have completely discussed with these 3 types of problems. One is based on the cross sectional view. I have explained why we need DNW insertion and why the tool is showing the problem. Okay, this is our schematic view. So in our schematic view, so you have to understand, right, most of the time the NMOS signal should connect to ground, but that is not the case. In some case the NMOS body signal which we don't want to connect to ground or which we don't want to connect to body. Okay, so this is a special signal. Okay, some device, if you want to connect some device with based on body biasing, or else if the device performance is not good, so you need to control the device based on the body. So in that case, a separate signal should connect to this M1 signal. Okay, the separate signal should connect to body of this M1. But if you connect the separate signal to this body of the M1, other nets also will get the same signal, because all the M0, M1, all the NMOSs in the circuits having the same substrate, so which is called a global substrate. Okay, so now this is our first problem, why we need a DNW and where we have to go for DNW. So now we'll discuss about these things. First thing, when the N channel MOSFET, which the source and body which is connected to the same signal. Okay, so there is a signal, okay, there is a net called body and one more net called ground. Okay, so source connection and as well as body connection, if these two connections are, if two nets, okay, so we have two different situations right now, right? So first thing, we will take an example of M0. In this M0, body and source, the both nets are connected to the same signal. In this case, unless if the device is not critical device, if the device is not affected by the ground, or if the device is not introducing, or if the device is not creating any kind of noises or any kind of disturbance, so DNW is not needed for this M1. Okay, so DNW is not needed for this M0, but compulsory we have to go for the DNW insertion or deep Nwell insertion in the case of M1. So the case of M1 is totally different, even though if the device is not critical, even though if the device is not creating any noises. Okay, this is a very pure and proper device which is not at all affecting any neighborhood devices. But since the body connection is different from the general body, so general body in the sense I am telling about the local global substrate. So the global substrate by default that will be connected to ground, but here this device has to be connected to the secondary substrate, so that is called a local substrate. So when you want to isolate the local substrate of device from the global substrate of the common devices, so we have to go for the DNW method. So in our next video, we'll discuss how to insert DNW ring from the layout point of view and the cross-sectional point of view, and how DNW is resolving these kind of problem. So this is what the problem we have. So this is what the situation we have. In this situation only, we have to go for the DNW insertion. Okay, particularly based on the body. And one more thing, if the device body is getting the different signal, so these kind of devices are called self-biased device. So wherever there is a self-biased device, so self-biased in the sense the device is not by default connected to the global signal, which is called ground. Okay, so the device is not connected to the global substrate. Instead of that, the device is getting biased from the self signal. So the self signal is called body signal, that is the self signal. Okay, this is not a global signal or this is not a common signal. Since the device is getting the self signal, okay, self signal in the sense that is body. Okay, so these kind of devices are called self biased device. Okay, and second answer is, wherever there is a self biased device, compulsory we have to go for the DNW method. Until unless if you are not doing DNW method here, the LVS will not clear. So this is what our LVS shows. The P substrate, that is called a soft check error. So there is a conflict between, see here it is showing very clearly, here it is showing the net ground is selected for stamping, rejected by body, and the net ground is selected for stamping, that is also rejected by body. And second problem is also here the same thing, cell. See, this is how the tool will show the error to you. In the comparison result it will show some different errors. So you are not able to understand why this kind of error the caliper tool is popping up, because of the reason, okay, this is a kind of stamping error, it is conflicting with the body. So that is why we have clearly explained based on the cross sectional view of these two diagrams. So I have clearly explained what is the cross sectional view of these two diagrams and why it is getting the problem and why the tool is showing this kind of problem. So in our second video we will discuss how to clear this LVS issue and how the DNW will help to resolve this kind of problem.
I hope I have given some valuable information to you in this video. Thank you for watching my video. If you like this video, please click like button and share this video to your friends. For more details about this video, please contact us to my email ID and follow us on my Facebook page and Twitter page, and kindly subscribe our channel and don't forget to click the bell button.